I'm here to discuss the one of the topic of computer programming one in C language, which is the recursion. So, when you enter deeper into programming with C, you'll come across problems that requires elegant and compact solutions. That's where recursion in C comes into play. So, um, it's a powerful concept that helps break complex problems into smaller and more manageable parts. Next page is learning objectives. By the end of this lesson, you should be able to define recursion and explain how recursive function works in C. The number two, identify the two required components of any recursive function. Number three, write and understand simple recursive programs such as factorial, Fibonacci, and the last one is reverse a string. Number four, trace the execution flow of recursive calls step by step. Then the last part is explain the advantages and disadvantages of using recursions. So what is recursion in C? Um, Recursion in C is a programming technique where a function calls itself to solve a smaller part of the problem until it reaches a stopping condition. Instead of repeating code with loops, recursion solves a problem by breaking it down into simpler version of the same problem. It continues calling itself with new values until a specific condition is met, known as the base case. Next page. When to use recursion in C? Problem with recursive structure. When the problem itself can be naturally divided into smaller subproblems, example, factorial, Fibonacci, and GCD. Then the next one is tree and graph traversal. So recursion is ideal for tree traversal, pre-order, in-order, and post-order, and exploring graphs. The next is divide and conquer algorithms. Algorithms like merge sort, quicksort, and binary search are best implemented using recursion. The next one is backtracking problems. So it is used in puzzle like Sudoku solver, N-twins, rat-in maze, and subset generation. The last one is nested or complex repetition. When nested loops would make code messy, recursion keeps it clean and manageable. So the next page is when to avoid recursion in C. Avoid recursion when performance is a concern or too much many function calls. Then the next to avoid is the recursion depth is too large, causing stack overflow. The last avoid is iteration provides a simpler and faster alternative. Next page. So here's the basic syntax of recursive function in C. First one is return type function name, the parameter, if statement, the base case condition, return value, else statement, then the recursive case, return function name, update parameter. So what are the two required components of recursion? First one is the base case. So what is base case? It is the condition where recursion ends to avoid infinite calls. Then the recursive call is, the recursive case is the part where the function keeps calling itself with a smaller or simpler input. So in this page, we have three examples of code for recursion. The first example is factorial recursion. This is the library, and in line 3, this creates a function named factorial that takes a number n. And the next one is base case. If n is equal to 0, the function returns 1. This is because by definition, 0 factorial is equal to 1. And it also tells the recursion when to stop. Then the recursive case, return n times factorial n minus 0. If n is not 0, the function calls itself again with n minus 1. So for n minus 5, it does 5 times factorial, 4, 4 times factorial 3, 3 times factorial 2, 2 factorial 2 times factorial 1, 1 times factorial 0. Eventually, factorial 0 return 1, and all multiplication works out to 5 times 4, 5 times 4, 4 times 3, 3 times 2, 2 times 1 is equal to 120. For int main, int num is equal to 5, print f, factorial of the specifier, %d, number, num, factorial, num, return 0. So, um, it sets number to 5, calls factorial 5, and prints factorial is of 5 is 120. The next example is Fibonacci recursion. Um, so this program prints the first 6 Fibonacci numbers using recursive function. The Fibonacci function returns 0 when n is 0 and returns 1 when n is 1. For any other number, it calls itself twice and adds the result of Fibonacci n minus 1 and Fibonacci n minus 2. In main, a loop runs from 0 to 5 and prints each Fibonacci value. The output becomes 0, 1, 1, 2, 3, 5. Next example is a reverse string. So this program prints a string in reverse using recursion. The reverse function keeps calling itself with the next index until it reaches the end of the string. When it hits null number, \0, it stops going forward. As the function returns back through the recursive calls, it prints each character, which results in the string being printed backward. In main, the string hello world is passed to the function and the output becomes this one. So we're done with the 3 examples of recursion. In this page, we are going to discuss the advantages and disadvantages of recursion. The first advantages is simplifies code. It makes the code cleaner and shorter, especially for complex problems like tree traversal. Next is natural fit for divide and conquer. Ideal for problems like merge, sort, binary search, and etc. Next is reduces code length, eliminates the need for complex loop structure. Next, better readability, easy to understand logic for problems that have a recursive nature. Last advantage is useful for data structures. Helps in handling recursive data structures like trees and graphs. Limitation of recursion. Next is disadvantages. One of the disadvantages of recursion is high memory usage, slower performance, and risk of stack overflow harder to debug. So to summarize the discussion of recursion, um, recursion is when a function calls itself to solve smaller version of a problem. It must have a base case to prevent infinite loops. Common examples include factorial, Fibonacci, and reversing string using recursion. Then the last part is recursion makes some problems easier to express but may be slower or use more memory than iteration. So that's all for today's discussion. I hope you understand our lesson. Thank you.